Hey guys, here we go. I'm gonna do a couple more example problems for you guys, just like I did before. Probably do the next two slides and let you guys work on the next one, and then we'll talk about how to do these analytically. Um, so the third page, the first slide has this picture. It's like a piece of a parabola, it kind of looks like, maybe y equals x squared. And then a straight line. Okay, but there's a jump here, which is that x equals 1, which means you're almost certainly going to ask us to find the limit when x is 1. But either way, we can look. Limit as x approaches 0 of f of x. So like we said over and over again, to find these limits from a graph, you look at the picture and you approach x from, you look at what happens as x approaches 0 from the left along the function. Look what happens as x approaches 0 from the right along the function, and then you see if those limits exist or not. So I'm just going to say the work. I'm not going to write it down, but you are certainly welcome to do so. So if I take the limit as x approaches 0 from the left, so I come towards 0 from the left on the x, the y is approaching 0. If I take the limit as x approaches 0 from the right of f of x, y is approaching 0 also. So since really because this function is continuous and there's no hole or anything, not that matters, but it's continuous there, that means that this limit is equal to 0. So good, that was pretty easy. Now I'm going to do the limit as x approaches 1 from the right of f of x. So I start with x is bigger than 1, and as x approaches 1, y is approaching 2. So this one-sided limit is equal to, like how it won't switch back, that's fun. This limit as x approaches 1 from the right is equal to 2. The next one says limit as x approaches 1 from the left of f of x. So there's 1, so I start to the left of it and I get closer and closer to x equals 1, and y is approaching 1. That's 1. There's a hole there, but it doesn't matter because I don't care about what happens at 1. I care about what happens as x gets close to 1. And as x is getting close to 1 from the left, y is getting close to 1. Now it just says the limit as x approaches 1. No left, no right. This means this is the two-sided limit maybe. It's like the limit, which means what is the way that we calculate these or we answer these questions is we look at the left-hand limit and the right-hand limit and we see if they agree. Pretty clearly, these limits do not agree. So the limit as x approaches 1 of f of x does not exist. So that's how you would do a problem like this. This one to me is pretty straightforward. I don't expect you guys to be able to do this at this point. This is a bigger picture. This is the second slide on page 3. The picture is technically more complicated, but really it's just another picture. You can see it's made up of like a bunch of curves and weird things, like a straight line there, and there's a curve here, and whatever, it doesn't matter. There's a jump here and a jump there and a hole there. Without even looking down here, I'm like, they're going to ask me what happens as x approaches 4, because that's where the jump is. And they might ask me about -1. They might ask me about -4. That's just where the graph does things that is, I don't want to say interesting, because you guys might not find it to be that interesting, but I find it to be more. Mathematically, it's more interesting at the jumps. So for A, the limit as x approaches -1 from the left. So -1 is here. So as I approach -1 from the left, y is approaching 2. B, as x approaches -1 from the right, so that's the same x value, -1, and I approach from the right, and y approaches 2. Without even looking, I'm almost certain the next question is going to be, what is the two-sided limit at -1, since they asked me about the left-hand and the right-hand limits. And there it is. The limit as x approaches -1 of f of x. No plus, no minus up here. That means it's the two-sided limit. I've already done all the work for this. I calculated the left-hand limit. It was 2. I calculated the right-hand limit. It was 2. Which means the two-sided limit is also 2. So now D, says the limit as x approaches -4. -4 is here. And there's a jump at -4, which means without doing a ton of work, I can just say right away the limit doesn't exist. When the function jumps like that, the limit's not going to exist. But just so for the sake of completion, as x approaches -4 from the left, the y value is approaching 3. And as x approaches -4 from the right, if I trace the function, the y value is approaching 4, it looks like. So since the left-hand limit is 3 and the right-hand limit is 4, this limit does not exist. I can't really tell if my handwriting is getting better or worse on this thing, but we'll see. All right, last one. Limit as x approaches 4 of f of x. So I approach from the left, and x is approaching 4, and y is approaching -3. As I approach from the right, x is approaching 4, and y is approaching -2. Since those do not exist, since those do not agree, -3 is not equal to -2. This limit also does not exist. So that's basically our technique for these graphical ones, is to look at the left-hand and the right-hand limits and see if they're the same or not. And when I say look at, I mean you trace the graph as x approaches that value, and you see what the y approaches. Then you trace the graph as x approaches that value from the other side and see what y approaches. Hopefully you'll kind of get the idea that if there's a jump like this, the limit's not going to exist. If there's like a hole at that place, the limit probably will exist. Yeah, the next video is going to be, I'm actually going to leave you guys the next slide, which looks almost exactly like this one, to do on your own. Maybe I'll post the answers or something, but do that one on your own, and then check out the next video, which is about how to do these things analytically. Bye.